Mathematicians often state the obvious, and we're going to do that numerous times during this lesson. We're going to start with three definitions. A right angle. A right angle is an angle with a measure of 90 degrees. Straight angle. A straight angle is an angle with a measure of 180 degrees. And congruent angles. Congruent angles have the same measure. Definitions are reversible. And to show what I mean by reversible, I'm going to reverse these three definitions as examples. So our definition was a right angle is an angle with a measure of 90 degrees. When we reverse it, we get an angle with a measure of 90 degrees is a right angle. For straight angle, the original definition was a straight angle is an angle with a measure of 180 degrees. When we reverse it, we get an angle with a measure of 180 degrees is a straight angle. And then for congruent angles, we have congruent angles have the same measure, and then angles with the same measure are congruent angles. And here's yet another definition. Theorem. A theorem is a mathematical statement that can be proved. And when that definition is reversed, we get a mathematical statement that can be proved is a theorem. And here's our first two theorems for this series of lessons. Just about every geometry textbook numbers their theorems, but I've never seen two textbooks number their theorems in the same way. So these numbers are mostly arbitrary, just to help us have a list for this series of lessons. But if you have your own geometry textbook, your list of theorems will probably have a different set of numbers. But our theorem 1 will be, if two angles are right angles, then they are congruent. And since a theorem can be proved, let's prove this theorem. We're going to use something called the two-column proof. And we start by looking at the theorem, and we take the part of the theorem after the word if, and that's the given. If two angles are right angles. Specifically, we're going to label two angles, angle A and angle B, and in most theorems, where possible, a diagram will accompany the proof of the theorem, as we have here. And then the thing we're trying to prove is that angle A is congruent to angle B. And in a two-column proof, we set it up like this. On the left, we will write statements, and on the right, we will write a reason for each statement. Statement 1 is we copy the first given. Angle A is a right angle. The reason is that's given. And then we can say that the measure of angle A is 90 degrees, because a right angle has a measure of 90 degrees. That's the definition of a right angle. Number 3 is the other given. Angle B is a right angle, and the reason for that is it's given. And then for number 4, the measure of angle B is also 90 degrees, and of course that's the same reason as the one given in step 2. A right angle has a measure of 90 degrees. And since both angle A and angle B measure 90 degrees, we can say that they're congruent in step 5 because angles with the same measure are congruent. Notice we've used symbols. We've used the little symbol for angle to substitute for the word angle. We use RT for the word right. And of course, you already know how to say the measure of angle A and the measure of angle B. And you know the congruent symbol and the equal symbol. There's one other thing that I allow. You'll have to see if it's allowed in your geometry course. But for reasons 2 and reasons 4, I simply allow definition of right angle. And for reason 5, instead of restating the definition of congruent angles, just write definition of congruent angles. So if you want to state the whole definition in your reasons, that's fine. But as far as I'm concerned, if the reason is a definition, just state that it's the definition and then state what it is the definition of. In this case, for 2 of our reasons, definition of right angle, and for reason number 5, definition of congruent angles. Now here's theorem 2, and I've already set it up. If you'd like to stop the video and write your own two-column proof, it's a short one. It's almost identical to the two-column proof for theorem 1 with a few substitutions, but you can write it if you'd like to practice, or you can see mine. Number 1, just like before, we state the given, only this time angle CAB is a straight angle, and that was given. Number 2, the measure of that straight angle is 180 degrees. That's the definition of straight angle. Number 3 is the second given. Angle XYZ is a straight angle. And number 4, angle XYZ has a measure of 180 degrees. That's the definition of straight angle. And since both angles equal 180, They're congruent because that's the definition of congruent angles, reason number 5. And now we're going to do something called a paragraph proof for each one. We set it up pretty much the same way, but instead of 2 columns, we write a paragraph that explains our thinking. And here's my paragraph for this one. It is given that both angle A and B are right angles. Each angle must have a measure of 90 degrees by the definition of a right angle. The angles must be congruent then by the definition of congruent angles. That's a paragraph proof for Theorem 1. Once again, if you'd like to stop the video and write a similar proof for Theorem 2, be my guest. It's almost an identical paragraph with a few word substitutions, and here it is. It is given that both angle CAB and angle XYZ are straight angles. Each angle must have a measure of 180 degrees by the definition of straight angle. The angles must be congruent then by the definition of congruent angles. In this lesson, we looked at 4 definitions: right angle, straight angle, congruent angles, and theorem. We also discovered that definitions are reversible. And 2 common ways to prove theorems are 2-column proofs and paragraph proofs. And finally, our first 2 theorems for this set of lessons: Theorem 1, if 2 angles are right angles, then they are congruent. And Theorem 2, if 2 angles are straight angles, then they are congruent.